Hello and welcome to the Math Jedi channel, where all you young Padawans will learn about the intricacies of inequalities today. Yes, we are looking at graphing inequalities and writing inequalities. Are you ready? Get your lightsabers and let's go. So inequalities, that's what we're looking at today, and inequalities is one of my favorite topics in math, mostly because it brings back some memories of being in grade 2, I believe. And in grade 2, my teacher was pretty cool. Her name was Mrs. O'Sullivan. My grade 1 and grade 2 teacher. She was my grade 1 and grade 2 teacher. Anyways, I do remember, though, that she taught about inequalities, like using the crocodile. And maybe your teacher also did that. So here's my little crocodile. It's not a very good crocodile. Here's my crocodile tail. And maybe little arms. Anyways, the crocodile always ate the bigger numbers. And you know, your teacher probably did something like this. It's a tried and true classic math teacher sort of thing. Crocodiles or monsters eating the bigger number. So that's the whole idea. So if you had two numbers here, let's say you had 5 and you had 3, the crocodile would go and eat the 5. So it's like that. Now that we're in, you know, not in grade 1 and grade 2, we're probably in middle school right now if you're watching this video. We need to start using some real words now. And those words are inequalities. And just quick little review. This sign here is called the less than symbol. And this symbol is called the greater than. And of course, if you go and you add a little line below it, like this, it's not only less than and greater than, it's less than and equal to, because that little line is like half a equal sign. So do realize that difference. So this is less than, but if you add that little symbol down here, it's less than and equal to. Get that word to in there. There we go. Just like that. So those are the inequality signs. And the whole idea is that those inequality signs will be eating the bigger numbers. So remember, we're always dealing with number lines here. So if you need some review of good old number lines, you got 0, and you got a bunch of numbers that go down this way. And on the other way, it goes -1, -2, -3, etc., etc. So you're just trying to figure out which number is bigger on the number line. That's basically all you're going to be doing. There are some phrases that you do need to know. So there are some very key phrases that pop up in math tests all the time that we must know. And if it's going to be on a math test, we better learn it. So the first one is more than. The second one is at most. At most. The other one is at least. Number 3 is at least. And the final thing, number 4, is fewer than. So let's use those phrases and let's think about kind of like real life scenarios. So let's say you had a scenario. So here's scenario number 1. Your friend, you don't need to copy these down, by the way, if you're taking notes from this video, which, you know, all good students will be taking down notes, of course. Your friend has more than 6 lightsabers. What a great friend. So if I said to you, your friend has more than 6 lightsabers, do you know how many lightsabers your friend has? You don't, do you? But you know that it's more than 6. So it could be 7. It could be 12. It could be 13. It could be 1,000 if he's an awesome Star Wars Jedi person. But we don't know. So let's say in algebra we said x is the number of lightsabers. Let's just say we went and did that. So I'm saying x is going to be how many lightsabers you have. Well, let's go and write an inequality then. So x is going to be, so number of lightsabers is going to be more than, so I'm going to use that greater than sign, more than 6, like that. But what if I said your friend has at most 6 lightsabers? So at most, well, could your friend have more than 6? No. Could your friend have none? Absolutely. Could your friend have 1? Yes. We don't know, but we know at most. So x would be less than or equal to 6. What if you said that your friend has at least 6 lightsabers? So that means it's greater than or equal to 6. He has at least 6 or more. That's cool. And then finally, what if your friend, your poor friend, has fewer than 6 lightsabers? So x would have to be less than 6. So that's just using those phrases, and those are the phrases that you're going to be hearing when you start to work with inequalities. And as we work with inequalities, you'll start to be asked to perhaps even graph them. So how do we go and graph inequalities? Like, how do I go and show those 4 scenarios? Well, we have a number line. And let's just keep with the lightsaber stuff, right? So I'm going to put a 6 here, 5 there, and a 7 there. Because it's all about the 6, right? It's all about the 6. And here's some things that you need to know. You always put an open circle above the number on the number line. And your circle is either going to be open or it's going to be closed, solid, completely colored in there. If it's open, like this one, that means you're going to use the greater than symbol or the less than symbol. If it's closed, that shows that it is equal to. So you're going to use the greater than or equal to, or the less than or equal to. So that's the difference between those symbols. Okay, so the open circle uses these ones, and the closed circle uses these ones, because the closed circle says it's also equal to. The open circle says it's not equal to. It's either greater than or less than. So back to your examples here of the lightsabers. If your friend had at most 6 lightsabers, so at most 6, or should I say greater than 6 lightsabers? Let's use the your friend had, greater than 6 lightsabers. Oh, that was really messy, wasn't it? It was. So greater than 6. I'm going to use what kind of circle? I'm going to use an open circle because it's greater than 6. It's not 6. It's greater than 6. And I need to draw an arrow now because I don't know what it's going to be. This arrow says it could be 7, 8, 9, 10. It just keeps going forever. So I put that arrow there. Realize this if it's greater than 6. But if I said, instead of greater than, I said at least 6. If I said at least 6, that means I could have 6, or I could have 7, or I could have 8. I could have 6, so I use a closed circle. And I go this way. If I said has at most, so say I said at most 6 lightsabers. So I could have 6, I could. Just for kind of space sake, I'm going to kind of squeeze it right down here. And normally I put it above it, but at most 6. So I go this way. But if I said I have less than 6, so less than 6, so I don't have 6, I have less than 6, I do an open circle, and I go to the left. Just kind of show that. So that's graphing just basic inequalities on a number line. Now, you're also going to be asked to start to not only just graph kind of simple things, like if I said, can you just go and just simply graph this on a number line? X is greater than or equal to 2. So if I said that, here's my number line. And when you make a number line, you always put the answer in the middle. and you put the other numbers on the other sides. What kind of circle is it going to be, closed or open? That's what you want to ask yourself. It's going to be closed. X is greater than or equal to 2. So is it greater than or equal to? So which way are you going to go? Greater than. What's greater than 2? 3 is greater than 2. So I'm going to go that way. Awesome. Great job. Now, you're also going to be asked to write inequalities. So if you were asked to perhaps write something like 5 times a number. So 5 times a number, and we'll use that number D, comma, is at most 10. So when you see that phrase, at most, you know you're talking about inequalities. So 5 times a number D, so 5 times a number, what does that look like? It looks like this, 5D, is at most. So what kind of inequality symbol are you going to use there? At most. So that would be less than or equal to 10, like that. That's how you would write it. Is at most. So 5 times the number D is going to be at most. It could be 10 or it could be less than, right? So what are all the different possibilities? Are you curious, math Padawans? Of course you are. So let's go and learn how to solve inequalities. I can hear the cheering in the background as we speak. So how do we solve inequalities? How do we do it? Well, here we go. We follow all the same rules that you've already learned in algebra. You've obviously watched my other videos and you've already learned about all the different kind of ways to solve one-step equations. So now we're just going to add the inequality sign. That's all. Not a big deal. So all the same rules. Okay, there is a special. There's always an exception. There is a special rule involving negatives. And I'm not positive I'm going to get to it. So there is one little extra rule you do need to learn. We'll see if we get to it today or not. We'll see. As you can probably hear, I'm kind of feeling a little bit under the weather, so I don't know if I'm going to actually go and do that part of the video today, but we'll see. So let's just say we had x plus 3 is less than 8. Okay, that sounds cool. Let's just imagine it was just like a regular an equation. So say it was x plus 3 equals 8. Okay, so your math teacher has already told you that you must follow the golden rule and do things to both sides and show all your work, and you would get something like this, x is equal to 5. Well, guess what, everybody? You do the exact same thing with inequalities. You do the exact same thing. So I'm going to subtract 3 from both sides, except this time we get something that says x is less than 5, like that. And then sometimes, because they're inequalities, your teacher is going to want you to go and graph them. So that's kind of the only difference here. So again, we put our answer in the middle, 5. We put 6 and 4. We put an open circle this time, and our arrow would go to the left. So all those numbers to the left are possibilities for x. So ask yourself, could x be 1? What's 1 plus 3? 4. Is 4 less than 8? It absolutely is. Could it be negative 7? Yes. Could it be negative 70? Sure. How about negative 700? How about 1700? It could be all of them. We don't know. That's why we go and use an inequality and we graph it. Well, that's not too bad. Let's see another one. You're like, hey, this is actually pretty easy. Hopefully. Let's have 6d equals 24. So for this one, how would you get d all by itself? Oops, sorry, not equal. See, I did it right there too. Let's make it less than 24. Let's go and just divide both sides by 6, just like you normally would. Just like any kind of equation. So those cancel out, leaving with d. So d is going to be less than 4. Oh, this isn't too bad. Let's try 2x over 3 is greater than or equal to 6. So for that one, you go and multiply both sides by 3 over 2. If you're kind of used to doing that way. I like to put this over 1 just to make my life a little bit easier. These go and cancel out, and then it leaves you just with x. Like that. and you're still greater than or equal to. And what does this all happen? I'm going to do some cross reducing here because that's cool. And there you go. X is greater than or equal to 9. Okay, are you ready though for the special rule? Okay, we're going to do it. Here we go. This is going to be exciting. What's the special rule, Mr. Douglas? What's the special rule? The special rule is this. If you multiply or divide by a negative, you must flip the inequality. Okay, this is an awesome rule. This is the only exception when solving inequalities. You must flip the inequality. So, what am I talking about? What am I talking about? Let's get on to an example. Here we go. Let's say it was negative 5x is greater than 10. Whew, okay, so how are you going to solve this? You're going to go and divide both sides by negative 5. As soon as you divide by a negative, and that is the key, it has to be dividing or multiplying by a negative. That's the only time this happens. Little alarm bells should be ringing and saying, meh, meh, meh. We must do something. We must flip the inequality sign. So if I flipped this, what would it look like? It would look like, oh, what color should I use? What would a flipped color look like? Ah, gold, so gold. It would look like this. So it goes from greater than to less than. That's what would happen. And what are we left with? X, still, right? Those cancel out. X. And then what's a positive divided by a negative? It's going to be negative 2. X is less than negative 2. So that's the special rule. You have to flip when you divide by a negative. Oof. You're wondering, what are the common kid mistakes? Oh, for sure you are. For sure. Common kid mistakes. Number one, here we go. Kids get this wrong all the time. 6x is less than negative 12. Okay. So kids go like, oh, I can do that one. I'm going to go divide by 6, divide by 6. I'm going to go x is, well, I'm going to leave that right now. But I know this is negative 2. And you know what a kid thinks? This is what a kid thinks. I got a negative answer. There was something my amazing math teacher said about negatives and inequalities. I think I'm going to go and flip it. Because he said something about negatives. So I'm just going to flip it. Did I say if your answer is negative, you flip it? Did I say that? I didn't say that. I said if you divided by a negative. Did you divide by a negative? No. Did you get a negative answer? Yes. Is that fine? Yes. You just leave it like this. Okay? You do not flip because you have a negative answer. Okay, so I see that happen all the time. All the time. The other time sometimes I see is this one, so number 2. Sometimes. And again, it's just children thinking or just remembering parts of lessons. So that's why you always want to be paying attention. So some kids go like this, and they subtract 2, and they subtract 2, and they're like, oh, I subtracted, there's a negative there. Should I go and flip it? No. No, you just leave it. You just leave it. So, again, the only time you flip is when you multiply or divide by a negative. That's it, that's all. All right, I hope you had fun doing inequalities, and maybe you remembered your alligator from your grade 1 and 2 teacher. Until next time, have a great day.
Thanks all you math Padawans out there. Hopefully you learned a little bit more about inequalities. Remember, you can always go down in there and subscribe or subscribe down there so you stay in tune with all the latest developments of math. Until next time, have a great day.